Hello! How we doing, my friend? Let's get down to the chatting part here. Yes. Hello, hello, hello! How we doing, Yusuf? I hope you're doing well, my friend. My day is going well. Jade, hello! How are you, Jade? I hope you're doing well this your fine afternoon, my morning. So, I hope you're doing really, really well here today, Jade. Today is a nice, wonderful day. I was playing a little COD last night, Jade. Just trying to improve and get a little bit better. So, hopefully, I'll be a little bit more of an asset next time we play. You're tired? Oh. Are you working today or did you work today? Yusuf, my day is going well already so far. Look who I already have in the chat. I got Jade and yourself. Well, I can't go wrong with something like that. Frankly, I don't think anybody could go wrong with something like that. Oh, you're at work for another 4 hours? You work the night shift there? Or do you regularly work nights? Or is it just kinda just varied all over the place? Just out of curiosity, really. What are we doing? Work, work, work. But remember, Jade. Alex, my friend, how are you? I hope you're doing well. You always work night shifts? Well, Jade, I will say this, Jade. Something that I haven't said on James's stream is that what you're always looking forward to is you're always looking toward financial independence and being able to stand on your own 2 feet, and be able to get those things that you want, to live the lifestyle that you want. So financial independence is always important. I know you're working hard toward it, and your music, man, you sing outstanding. You are a very good singer. So I hope that if you sell your single, that that sells really well. If you put it on Spotify or whatever, that it sounds very, very good. So I ain't gonna lie, absolutely outstanding. You should have confidence in yourself, Jade. You have a lot. You have a great gift. Alex, you doing good? I'm doing really well. It's currently on Spotify, iTunes. Perfect. Perfect. Wonderful. Wonderful. Now you need to do is promote it, and I think you'll be in good shape. Good morning, Cheska. Good morning. How are you doing this morning? Jade, I'm super proud of you. I'm super, super, super proud of you. You know, you put in a lot of time and effort into that song, and I know that you can even create even more beautiful music in the future. So you doing good? I'm doing great, Cheska. I'm doing great. Look at the positive vibes this morning, okay? Super positive vibes this morning, okay? Super positive vibes. All right. Anna, hello. How are you this morning, Anna? I hope you're doing well. Hope things are good. Jade, you know I always got your back. You and Milky. Like Jade, I always got your back, okay? That's how it rolls. Anytime you need to talk, anytime you need help, anytime you just want to you want to sit and chill and just have a nice time, come talk to me. I'm fine. I'm maybe just a regular dude, but everybody needs a pick me up now and then. If Milky isn't around, you could talk with me. So yes, FD, how's it going, my friend? Anna, great morning. How are you? I'm doing great, Anna. Like I said before, positive vibes. Positive vibes. I'm a beast in COD? What? What? I'm not sure if I'm a beast in COD yet. I just happen to have a good gun. Jade, the feeling is mutual. I appreciate you guys a lot. Age doesn't really matter. I know people say age matters. I said age doesn't matter. It doesn't matter how old somebody is. Everybody brings something positive and a good contribution at the end of the day. Jade, you have a great one, okay? I'll see you later on James' stream. Absolutely, 100%. Positive vibes. That's right. We'll get him next time. Yes. Hey, how's it going, Wade? I hope you're doing good this morning. Hope we're doing good. Megan, good morning. Good morning, good morning, good morning. Hope you're doing really well. Look at all these positive contributions happening already in the morning here. Ziggy. Ziggy, my friend. How are you doing? All right. I hope you're doing well this morning. I'm doing wonderful, Megan. Absolutely. Gotta finish a research proposal. Have a great lecture. Thank you, Alex. Thank you for yesterday, by the way. I appreciate that. Thanks for the words of encouragement playing some COD. You're doing all right. Excellent. I'm very happy to hear that. Oh, excelente. Excelente. Hey, man. Should be recognized for that effort. 100%. 100%! Okay. Gotta be recognized for that effort. Look at this. Yes, yes, my friends. We are on a good path to success. Success, indeed. Alrighty. Alright, we're about a minute or two away from getting things rolling here. So hopefully we will get things rolling. At least I hope so. Got to put that in. So, ooh. Ooh. Well, I guess I'll put that in later. Alright. That's fine, I can put it in later. In the document. Alrighty, let's get going here. Let's get going here, ladies and gentlemen. Alright, let's do this. It is now 11 o'clock. Let's go, go, go. Alright, time for the intro. Let's do this. Alright. Okay, let's get started today. Welcome back. Welcome back to Wednesday, end of the week time today. So today we are getting into Chapter 6. All right, so Chapter 6 is what we're going to be focusing on here today. Chapter 6, by the way, just to let you know, has just a couple of sections in it. So We'll do 6.1 here today, and then we'll finish up here with section 6.2 here next week. So chapter 6 is a fairly quick section. Some of these chapters here are very short, may have like 2 or 3 sections in it, so there's not a whole lot of, there's material in there, mind you, but just not a whole lot of sections. But getting through these sections here should be rather easy. So that should be plenty to do. All right, so let's go ahead and get going here. All right, let's go to the big board and let's see exactly what we're working with here in today in section 6.1. All right. All right. All right, so let's go to the big board here. We have section 6.1 here. Today, we're going to be talking about random variables. So let's discuss what we're talking about here today. We're talking about our objectives here today, which I have neglected to put down here. Reasons. So our objectives here today are to talk about, I'm going to talk about discrete and continuous random variables. Okay, we'll talk about how to compute and interpret the mean of a discrete random variable. All right. We'll also talk about interpreting as well computing the standard deviation. So compute standard deviation of a random variable of a discrete random. Good morning, Cool Dad. How are you, my friend? Good morning, Cool Dad. I hope you're doing really well today, my friend. I hope your kids are doing good as well. Very good. I'm doing excellent, my friend. Absolutely outstanding today. Absolutely outstanding today. All right. So these are the main topics here of what we're going to be covering. All right. These particular objectives. Yeah. All right. That's fine. We'll talk about that. All right. All right. Let's go ahead and do this here. So in section 6.1, we'll talk about a random variable. So what is a random variable? Let's look at question 1 here. What is a random variable? So a random variable here is a numerical measure of an outcome of a probability experiment. So its value is determined by chance. So notation here is we use a capital letter. Let's say X. Now, we've already been using a random variable of some variety. So what's an example here of a random variable? Well, you can say, like, oftentimes just write it in for you guys. I say, well, what's the probability that I roll a 1? Right? So if I roll a 1, right, then that's basically like a possible outcome on a 6-sided die, for example. I roll that 1, and then we figure out the odds there, like 1 out of 6 or whatever. So it's like, there you go. You got it. Simple enough. All right, so I usually write that in, but instead of writing in rolling a 1, let's just say we had a list of all the possible outcomes of rolling anything on a 6-sided die, let's say 1 to 6, and instead I replace the roll of 1 with X, and I arrange the probabilities in a table instead. Okay, so that's essentially what we're going to be looking at here in this particular section. It's just another way to rehash exactly what we had talked about here, what we have talked about before. Uh, yes. By the way, I guess I'll say this right now, because it was forgotten to be asked last time here. Today's drink of the day. All right, today's drink of the day is Mitsuya cider. Okay, this lecture is brought to you by Mitsuya cider. Mitsuya cider tastes absolutely outstanding. It is carbonated and very, very delicious. I haven't had it in a while. So a nice tangy drink, 100%. So yes, very, 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 very good. I'm gonna try this right now, actually. Go. Oh, all right. I missed that. I missed that very much. Oh, goodness. All right. This is 6.1. Yes. This is definitely 6.1. Absolutely 100%. I don't know if this is caffeinated or not. I don't know if you consider this pop. It's a little different than pop, maybe. Maybe it is. Maybe it is Cool Dad. Chase, how you doing, my friend? Inverse trig functions. I will be available in about a couple of hours. So, or maybe like at 2 o'clock. So 2 o'clock, I'll be available again there, Chase, if you need me to help you with some trig. So, is it possible to have exact values? Example: cosine of sine inverse of 1/2. Yes. You just have to use u substitution with that, by the way, Chase. So set u is equal to the inverse sine of 1/2, and then set sine. Yeah, just set sine of both sides, and then basically and then you'll have sine of u is equal to 1/2, and then basically find the angles that satisfy that within which two quadrants, which will be the first quadrant, which I think sine of 1/2 has to be the y coordinate. So I think this has to be like pi over 3. I think it's pi over 3. And then you take cosine of pi over 3, and then there you go. You got a winner. So, okay. Moving on. All right. I think it's pi over 3 or pi over 6. One of those two. Um, all right. So, let's go ahead and take a look here at number 2. Let's take a look at number 2 here. All right. So, number 2 says, what is a discrete random variable? All right. What is a discrete random variable? So a discrete random variable here says it's a random variable that has a finite or countable number of values. Now, we talked about this before back in chapter 1. Back in chapter 1, we had discussed discrete and random variables. Okay? Well, discrete and continuous random variables have the same exact definitions as we talked about back in chapter 1. So there's no difference in how we're going to approach what we did in chapter 1 in terms of its definitions to how we apply it here in chapter 6. Okay, absolutely no difference. They are exactly the same thing. Okay, so we have a finite or countable number of values here in a discrete random variable, and in a continuous random variable, we have an infinite number of values here. The only difference is how you can map it out on a graph. Again, a discrete random variable would be like points, whereas a continuous random variable would be like a line, okay, because it can take on any value. Okay, but that's really not it's not too important in that regard, because of what we want to do here in this section is really go ahead and use this and calculate with it. Okay, so we want to calculate with it here. So we'll see how we can do that here in just a second. Okay, before we do that, we got to talk about you got to establish one more thing here, and that is, what is a probability distribution? It's again a distribution that represents possible values of random variables and their corresponding probabilities. Again, the properties are the same as before. If you add up all the probabilities, we all know that that should equal 100% or 1, and that all probabilities have to be between 0 and 1, okay, including 0 and 1 if possible. And that's pretty much it. Okay, so those are the same two properties we've been talking about pretty much throughout this entire book. All right, so we know that that has to be the fact there going forward. All right, so nothing's changing. It's all exactly the same. It's just a rehash of what we've already talked about here at the beginning of chapter 5 and in chapter 1. So nothing changing in that regard. Now, the real question is, where is this useful? Why is this a thing? Why is this here? Why are we here? What is life? So let's talk about that right now. Let's talk about number 5. Just to suffer. Just to suffer. No, 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 my friend. No, no, no. I guarantee you, Cool Dad, math is not just for suffering, okay? Math is not just for suffering. I understand, yes, suffering may be part of it. No, there's a lot of good insight that you can get from this, I assure you. Baby, don't hurt me. No more. Well, unfortunately, Wade, I'm gonna have to, I can't guarantee you anything. Math is a subject that may hurt you a little bit. Maybe brain cramps is bound, just a smidge. No. But look at it this way. Okay, look at it this way. See, when you get to learn these things, then maybe later on when you have a family or whatever, if you have kids in the future, maybe cool dad's already there. You could teach the future generation exactly how you did it. Okay, there you go. All right. Well, let's talk about the two important things here in a probability distribution. Someday I'm going to get through this section. Someday. All right. Number 5. How do we find the mean slash expected value of a discrete random variable? So, what I have here on the screen is I have the notation here, either mu of x or e of x. We'll talk about that here in just a second, which is equal to sigma x times p of x. So basically, in words, this is the sum of all the random variable times its respective probability. So just take that random variable times the expected probability, and that's what we get here. Now, the most important part as part of this practical application of this particular section comes from the idea of expected value. Expected value is actually fairly important, okay? It gives exactly as it mentions, it gives an expectation of what you should get given a particular probability distribution. This is especially important in manufacturing, for example. In manufacturing, you want to actually build around a probability distribution. So, for example, if you're trying to look at defective lots, how many defects should you find in a lot of parts? Okay, so you make a bunch of parts and you're inspecting them, you're going through quality assurance, and you will have an expected value. You say, okay, you know what, I should be able to find on average, two and a half, close around two and a half parts per lot of 100 that should be defective, okay, or does not meet QA standards. All right, if it doesn't meet, if a lot is either way above that or is above that, then maybe that lot is bad in general, and maybe you throw it away and you say, well, I wasted a lot of money. Too bad, so sad. You know, um, it wouldn't be good for distribution. So that could negatively affect a business if you're not careful, right? That could cost you millions of dollars and potential customers if you're not quality assurance checking your stuff there. So that's something that is fairly important. So expected value actually has a legitimate contribution into what happens in the real world. Now, let's take a look here at I'm going to bring up the book here, and we're going to take a look on how we can see how expected value works in other scenarios as well. Let's take a gander, shall we? Wahaha. Yeah, that thing. Uh, that thing. Hey, Lina, how are you? My math lab is not working. Um, Wait, why is it not working, Helena? Let's see. I see you on the roster there for Matho 97 there, Helena. So you are good to go in that regard. The network is down. I just brought up my math lab. So you should be able to try again. Either that or refresh your screen because I'm on my math lab right now. So I so try now. Try now, Hulina. Okay. I'm on right now. I'm on my math lab right now. Alrighty. Okay. So let's take a good look here at a couple of these. So let's look at that one there. All right. Let's look at number 18 here. All right. On the in the book, and I'm gonna kind of half screen it. So half and half this a little bit, and we'll bring up the paint tool. Oops. Okay. Yours hasn't been working either. When did you guys try? When did you try, Aaron? Like, was it just like yesterday? Because sometimes my math lab does go down for working on maintenance and whatnot. So I obviously don't have any control over that part there. If you have tried with my math lab, so there are parts of my math lab that I don't have control over. So one is when the servers are up. So you tried Monday? Try just now. I just got in just now. It's not working? Is it not working right now? Or did you guys make sure you turned off your ad blocks and things like that? Yeah, just refresh the page. So refresh the page with F5 if it doesn't work the first time. Okay. Let me put that in the chat there. So just refresh here. Okay. Yeah, I know. Excuse me. Okay, it works. All right. So maybe it goes down. Maybe for maybe a few hours during the day. Again, I don't know. But if it does, just hit F5 to refresh. That There we go. All right. So hopefully that's a nice little fix there. That'll be helpful. Alrighty. Let's go ahead and look at number 18 here. Number 18 says, in the following probability distribution, the random variable x represents the number of marriages an individual aged 15 years or older has been involved in. Okay, and so here we see x is on the left-hand side, all right, how many marriages that a person has, all right, and the probability that they are in that many marriages. So again, 0 marriages, here's the probability with 0 marriages. 1 marriage, here's the probability of 1 marriage. 2 marriages, here's the probability of 2 marriages. 3 marriages, 4 marriages, and 5 marriages. Okay, so we have again, this would be representative here, number 18, of a probability distribution. Okay, now the question that it asks here for this particular guy says, let's compute and interpret the expected value or mean of this particular probability distribution. All right, so we're going to do, again, we're going to compute the mean. Now, in order for us to compute the mean here, let's go back here for just a moment, okay, to the document here, to the Word document. So here we have to take the random variable, or again the result, and we have to multiply it by its respective probability. So for us to do that, in order for us to do that here, and we're going to add all those together, of course, we're just going to take 0. So here's all we're going to do. We're just going to take 0, multiply that by 0.272. We'll add that to 1 times 0.575. All right, plus 2 times 0.21. Okay, worked. Excellent. Plus 3 times 0.004. Plus 5 times 5 looks pretty bad. Plus 5 times 0.001. Okay. So this is the this is how we can figure out the mean here for this particular probability distribution. Let's go ahead and put that in the calculator there. All right. That's all we're going to do here. And does anybody have an answer for me here? Anybody have an answer for me here? Da, 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 da. 0.0 point, oh, not 0.0, 0.834. That is, check that one more time. What about the probability of 4? Did I skip that? What did I do? Hang on a second. Let me check about that, DMAR. So I got 2 and 0.21. Oh, I skipped that. Oh, I'm so sorry. You are correct. Thank you, DMAR. You are correct. All right, sorry about that, guys. DMAR is absolutely 100% correct. I did skip that on accident. All right. So I need to add 4 times 0.04. That's what I skipped there. I skipped 4, and I accidentally mixed the two probabilities together. So let's try that again. There we go. That's a little bit more appropriate here. DMAR's the only one awake right now. DMAR is legit. You can't argue with greatness. Thank you, DMAR. So we get, okay, that is correct. 0.919. That is correct. So let's talk about what this represents. Let's talk about what this represents. All right. So what this represents here, what this represents is that this is the expected value, okay? The expected value underneath this probability distribution of how many marriages Again, on average, that's why we call the mean / expected value. How many marriages that a typical person 15 or over will have in their lifetime. Okay, so in this case here, 0.919 marriages. Okay, Demar, I bow down to your greatness, my friend. um, but yes, to interpret this right, you have a 0.919 marriages, okay, on average for a person that's 15 years or older. So close to one on average, all right? So, or a touch under one, if you want to call it that. So, is that realistic? Of course, you can only have like whole number marriages, mind you, but it does give you a pretty good idea about, what a majority, what the statistics will say in terms of how many, say, for example, in this case, how many marriages a person who's 15 or over is going to have, right? So that is very important. All right. So that's how we can compute the expected value here in this instance. Now, let's talk about other half of this question, because there are two halves to this question here. So let's talk about the other half of this question here, which is, of course, if we talk about the mean here of a particular distribution, we also talk about the standard deviation associated with that as well. So that's what number 6 here is talking about. So number 6 says, how do we find the variance and standard deviation of a discrete random variable? So how do we find the variance and standard deviation of a discrete random variable? Okay, so here we're given a formula here. Now, I'm just going to point this out here for the formula you see here on the screen. You do not need to memorize this formula. This formula here is not something I'm going to have you memorize. All right, it does look fairly confusing. I ain't gonna lie. That's why I didn't even put it in words here. Uh, it's just it is a little bit of a tougher go. So I'm like, okay, let's not make things more confusing. In any case, let's take a look at how we can find the standard deviation, which is another part of this problem here in number 18. So let's find the standard deviation here. Now, as you can see, based on the formula you have on the screen, it would take a lot of work if I were to type this out, write it out, and do all the handwork here. Instead, of course, we're going to go ahead and use our friend, the calculator. All right, let's take a look at the calculator here, and let's see how we can go ahead and work with that. He was like, yeah, I don't want to do it. Like, no, please, please, God, no. All right, all right. So, what we're going to do here first is we're going to go ahead and hit the stat key here. So we'll hit the stat key here, and we're going to go over to edit. Okay, so we'll hit the stat key here under calculator. We'll go over to edit. If you have existing lists, we're going to go ahead and clear those out. So I'll hit clear and enter. Highlight the list, clear and enter. Okay. Now in list number 1 here, what we're going to do is we're going to put all the values of x here in this instance. So we're going to put all the values of x here. So all our possibilities, 0, 1, 2, 3, 4, and 5. Okay, so these are all the possibilities for x. And in list number 2, we're going to go ahead and put all the probabilities associated with that as well. 0.272, 0.575. Wait, what? I've been doing that every single time, my dude. Oh no. Yeah, if you've been doing it step by step like that, oh no. That does take a long time to do, admittingly. Yeah, because we're gonna be. Oh, okay. That's fair. I could have sworn I've been doing that every time. Well, anyway. Um. All right. So this is the list that we should have there in our calculators. All right. Um, you found you found out why I said yes, yes, yes. Oh no! Oh no! Oh no! Calculator calculator has batteries now. Kristen, if you want to get L1 and L2 back, you'll have to hard reset your calculator there if you want. So if you're going to hard reset your calculator there, Kristen, let me go back here for just a second. You want to hit the second key there, Kristen, and you want to hit the plus key on your calculator. Hit the second key and the plus key on your calculator there, Kristen, and then go down to number 7, which says reset, and hit enter. And then just hit enter on number 1, which says all RAM, and it will clear out. It'll just clear out your entire RAM and reset everything over. Once you do that, then re-enter, go back into your lists menu and re-enter the lists. So Ziggy, you might want to do that as well. All right, so for those of you who have screwed up your lists here, okay, remember, you want to hard reset your stuff there, okay? So, again, to hard reset here, hit second and plus. Want to go down to number 7, okay? And again, 7 is reset. Go to number 1, all RAM. Hit enter on all RAM, and then go back to, once you go ahead and hit enter on all RAM, it'll hard reset, and then you can hit the stat key there and go to edit and then enter in your lists. All right. So be sure about that part there. Okay. It does. It's just it does if you want to rename them that way. That's fine, but then you won't have all the designations put down. So I mean, if it works, it works. I ain't gonna lie, Megan, but uh, then you have to manually put it in for every other list that's in the calculator. That tends to be a pain. Yeah, so please don't hit delete at the top. Please hit the clear key. Please hit the clear key. Let me say that in all caps. Please hit the clear key. Yes, okay. So you highlight, hit the clear key, and hit enter. Yeah. All right. There we go. All right. All right. So that's what you should do in the future. All right. Just to let you guys know. Okay. Once you guys have this list in your calculator, I want you to go ahead and type in done in the chat. So type done in the chat once you have your lists in the calculator exactly as you see here on the screen. Dunny. Anybody else having issues? Done? Okay, good, Tristan. All right, Anna's done. Athena, hopefully you got yours. Athena, Demar, I hope you got yours on your calculator there. Okay, great. All right, perfect. All right, so now that we've got the stuff down here, we're gonna go ahead and hit the second key, hit the mode key. Gonna go quit out to the main screen again. Again, just making sure we don't enter anything in wrong in those lists. All right, we're gonna go ahead and hit the stat key here once again. We're gonna go to the calc submenu this time, of course. All right, and we're gonna once again here take this exactly as it is. Okay, so meaning to say, I'm gonna go ahead and hit enter here on one var stats. Okay, so one var stats is still gonna be our friend here. We want our list here to be L1. That part is true. Okay, so we want our list here to be L1. And now we want our frequency list here. Frequency here in this particular instance is going to be our L2. Okay, so second and 2 here to get L2 to show up on your screen. All right. Everybody good so far? Yes. Yes, that's correct. So do one var stats, L1, comma L2. That's correct. The comma key here is right here, right where my mouse is hovering. Okay, so again, if you have the older style calculator here, let's take a look here one more time. What should it look like on your older style calculator? It should look just like that. Okay, it should look just like that on your older style calculator. Okay, so one var stats L1, comma L2. And then I'm going to hit enter on that. Okay. And go ahead and everybody type in done in the chat if you have exactly what you see here on the screen. So the comma is right here next to the parenthesis. Right here, Megan. Right where my mouse is. I'm circling it right now. Right above the 7 key. Dunzo, nice. Donzo. Okay, good. So the one thing that we're going to look at here is we already found the mean here, the expected value, 0.919. But now we also have this standard deviation, which is right here at 0.7392. Okay, so we have the standard deviation here at 0.7392. Okay, good. That's Hanzo, not Hanzo. It's Hanzo, not Honzo. And no, my favorite character on Overwatch is Junkrat. So, because Junkrat is just stupid spam. And sometimes you're just in the mood for stupid spam. Check your numbers there, Feiner. Okay? And your list. Now, I do want to show off one more thing there. My favorite kill of all time in that game was with the Junkrat Riptire. I got a 5-piece with it on Temple of Anubis. Totally worth. Frequency list is L2, correct? Yes, that is correct. That is right. Hit second and 2 there, okay? Second and the 2 key. Okay, cool. Okay. Now, one of the things that you guys asked me from the previous test there was talking about variance. Um, and I know some of you had like a technical question regarding the variance part there. So let's talk about that here. If you want to find the variance of this here, and if you want to kind of find it, with the MyMathLab way of doing this, all we're going to do for the variance here in this particular instance is what we're going to do here specifically is we're just going to take this decimal that you see here, okay, for our standard deviation, our 739 215 1243. We're just going to take that and we're just going to square it. That's all we're going to do to find the variance here. There's nothing too fancy going on here because the variance is always going to be the square of the standard deviation. So I'm just going to do this whole thing out here. Actually, I should probably check that again. Let me check that one more time. 1243. I didn't really write that really well. Sorry about that. All right, so point 739 215 1243, and all we're going to do is square it. And so here we get our variance here to be 0.5464. Okay, and that's it. Yep, 0.5464 is correct. So that's our variance there at the end of the day. So if it does ask you for variance, you know exactly how to find that without too much trouble. Okay. Yeet indeed. All right. All right. Any questions? Any questions about that? Any questions about expected value and things like that for right now? No questions? Okay. You guys. All right. I'm going to ask a couple more questions in relation to this example. Okay. But these questions here are very quick and easy, so we shouldn't have too much of a problem with these questions. All right. They're just probability questions here. So what's the next part here is what's the probability that a randomly selected individual was at least 2 marriages? So the probability of at least 2. So, hey, Go Mash, how's it going, my friend? Um, what's the probability of at least 2? What do you think the probability of at least 2 marriages is according to this probability distribution? Definitely not. So according to the probability distribution here in number 18, what is at least 2? Okay, that's correct. 2, 3, 4, and 5, right? That's correct, right? So probability of 2, 3, 4, and 5. So if we added up all those probabilities together here, right? Because so understand this. We're already given the probabilities of each one of those, right? So all we have to do is just add them up straight up. Okay. All right. So we're just going to add this up together, and you got 0.153. Is that right? 0.153. All right. So 0.153 is the correct answer. Yes. All right. All right. Good beans. All right. uh, all right. Any questions about that? Yeah. So again, remember, wording here does mean a lot, right? Pretty straightforward. Pretty straightforward. Okay. Now I do have a question that I would like you guys to do. Nom indeed. Actually, I don't have noms right now. I think I'm gonna have to go out and get some noms. So double drink duty today. All right. Now, where is expected value really helpful here? Well, surprisingly enough, expected value is very useful in one particular field amongst most particular fields. Of course, it's used in a lot of different fields, but think of casinos. Think of gambling. Yeah, gambling. We talked about the lotto last time. Well, let's talk more about gambling once again. All right. Let's do this. All right. So let's take a good look here at number 27. All right, so I'm actually going to put this full screen here. And I'll probably zoom out just a smidge. Oh, okay. Okay, 27 says is a blackjack game. So I'll go ahead and read this off here. And blackjack. Blackjack is a popular casino game in which players dealt two cards. You try to get 21, right? As possible, you try to get 21 as close to 21 as possible. Okay. Oh, that sucks, man. Yeah, if you have a gambling issue, yeah, you shouldn't gamble too much. It's no bueno. No bueno when you gamble too much. Only gamble what you're willing to lose. But yeah, that sucks. I don't wish that on anyone. But at least you can understand your expected value of winning in a blackjack game. So the dealer plays last and must draw a card with the 16 or hold with the 17 or more. The following distribution shows the winnings and probability for a $20 bet. In cases where the dealer and player have the same value, there's a tie called a push. All right, and then, of course, here is your probability chart here. All right, so we're going to be answering a couple questions here. So, want the expected value and how much we will win or lose over 40 hands. So let's put both of these questions down here. Yeah, just give me just a second there, Athena. I will certainly do that. Definitely. There you are, Athena. And they nada. And okay, so we're just going to answer two questions here for you guys. Letter A, what's the expected value here, which is just e of x? What's the expected value here? And letter B, how much should we I've also taught you how to win an instant tickets. All right, so how much are we expect to be how much will we expect to win or lose over let's see. Let's say in 1 hour. Okay, so this is the question here. 1 hour we can be dealt 40 hands. Okay. So in 1 hour we get 40 hands. So how much can we win or lose over 3 hours? Okay. All right. So let's take a few minutes here. Let's have you guys give this a try. Okay. Go ahead and give this a try here. Let's take a couple of minutes. All right. And let's see if you guys can answer both questions. So we're going to come back here in about maybe 2 or 3 minutes here, and let's see if you guys can get the both of these parts here for number 27. Hey, Aiken, how are you doing? Doing very, very good today, my friend. Gomesh, say something nice. It is a wonderful day today, Gomesh. There is a lot of positive vibes. Hey, there you go. It's a boring day until some of your PC parts arrived. Very good. You honestly don't understand? Well, take a look at your notes there, Athena, about finding expected value. So first do expected value, all right, just like we did the last example, all right? You'll need to follow the notes there with the probabilities. So just take the winnings, right? And you'll need to multiply by, again, the particular probability. So and you'll need to add those together in order to see how much you make or lose. Hmm. Don't forget, guys, this negative 20 does have a very big bearing in this problem. So don't forget the minus 20 part there. Think about it for a second there. Yeah, don't forget about that minus. That's a big deal because that's essentially you losing that hand in blackjack. So if you lose that hand in blackjack, right, you lose $20. All right, we'll take a few more, maybe 30 more seconds here. See what people got. All right, Ziggy wants to be drinks. Thank you. All right. Okay. Let's take a look here at our expected value. All right, so Megan says she got negative 0.0566. All right, let's take a look at how we can find our expected value for a game of blackjack underneath these conditions. Okay, all we got to do is take our winnings and we're going to multiply it by our probability. We're going to take 0 times 0.0982 plus 30 times its probability, its respective probability, 0.0483, plus 20 times 0.39389, sorry, 0.389275, and then plus negative 20 times 0.464225. Now, if you did this out on your calculator here, and you added these together, what you should have gotten here is exactly the value of negative 0.05. This is what you should have gotten here for part A. Did everybody get negative 0.05 here? Okay, I'm waiting. I'm trust me, I haven't moved anywhere. Okay. I'm not gonna move an inch. Okay. Let's see where things went wrong there, Ziggy. I think you said it was that negative that you had there, so hopefully you got that answer there, negative 0.05. Yes, okay. Yeah, yours was off by the point the 6 at the end there. We're off by that. So make sure that you put in all the numbers there exactly. Remember, I think maybe I don't know what you did, Megan, but if you rounded, don't round the probabilities. You just wanna use the numbers straight up. Any other questions before we move on? I'm not sure. I don't see what's on your calculator there. But be sure you put those. Maybe enter. Yeah, it could be you entered the numbers in wrong. It could be you just switched around 2 decimals. Maybe you switched around like the 2 and the 7. Maybe you put 725 instead of 275. Could be something like that. All right. Okay, so let's talk about what this represents, okay? Let's talk about what this represents. All right. So the important part here is that, okay, we got negative 0.05, but what does this actually mean in the context of this problem? In reality, when we look at this problem here, okay, in terms of blackjack, this is basically the average value that we will make or lose for every hand of blackjack that we play. So for every single hand of blackjack that we play, all right. So let's put it into words here, okay? Because I want you to understand like why is this actually important in like real life. You're probably saying this doesn't have any application. In reality, it actually does. So the meaning is this: is that for every hand of blackjack, we will lose on average 5 cents. So 5 cents per hand. Okay. If we played an unlimited amount of times. So this is the important part here. If we play an unlimited amount of times, let's just say for example, we had an unlimited amount of money and we played an unlimited amount of times. Okay, over time, right? We using like the empirical rule, over time, we're going to lose on average 5 cents per hand. Okay, that's essentially what expected value is telling you over the long term. I should expect to lose on average 5 cents per hand. Some hands I'm going to lose the $20. Some hands I'm going to get $30. Some hands I'm going to, I'm going to go on a hot streak. Some hands I'm going to go on a cold streak. Whatever the case may be, but if I average everything out for whatever reason, I'm going to go ahead and lose a 5 cents per hand. Now that's actually not very good, because what that means is that before you even walk into the game, well, as we all know, the house always wins. This is a way you can quantify how much the house will win on that particular game. Blackjack, as you know, is better than some other games in a casino. Some of the games in a casino have lower expected values than even that. So, for example, here, I believe like other games like roulette. Roulette, you lose. There's another game for roulette. Roulette, you lose like 26 cents. I think that's what it is. If I remember that example from a long time ago. You lose like 26 cents per roll, which is really terrible. Okay, 26 cents per throw on a roulette reel is really good, really, 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 really awful. Okay, I mean very, very awful. So, um, you never play roulette. So, roulette is one of those games you should never play. All right, probably one of the worst games in the casino by far and away. If you want to play like actual games that, yeah, I know you don't gamble and such, but if you ever go into a casino, you either stick to a couple of games in a casino. Blackjack is one of them. For at least you can influence the odds in your favor if you kind of count cards a bit, or again if you play poker in a casino, well then you're playing against other people who have money as opposed to the house. So you can play poker in a casino. I've done that before a couple times. Slot machines, slot machines aren't truly RNG, but slot machines are not completely RNG based. So they're mostly They're supposed to be randomly number generated. They're not completely randomly number generated. It depends on how much money goes into the machine and kind of sometimes what how much money you put in at one time. But yeah, they don't give a good return necessarily. One of the issue, yeah, well, casinos are supposed to be bright and vibrant, so that way they lure you into the game. Yeah, the GTA fun. Yeah, that doesn't count. The GTA 5 casino does not count, sadly. But yeah, like the real casino there. Um, yeah, you might want to stick to both of those games. You guys are great. You're like, I just laundered. I just went to the laundromat. I laundered like $500,000, on the RP server. Now I want to gamble it at the casino. Oh man. Uh, all right. So, if 1 hour is 40 hands, how much can we expect to win or lose over 3 hours of playing blackjack? How much can we expect to win or lose over 3 hours of blackjack if 1 hour is equivalent to 40 hands? What do you guys think? What do we get for part B? What is the answer to part B? Yes, what do we multiply? I don't disagree with that. What are we multiplying though, Athena? What do we multiply here? $2. Where do we get $2 from? I'm a little curious. Okay, 3 hours times 40 hands. This part I agree with. Oh, getting to that $2. Okay. So we have 120 hands in 3 hours times 0.15. You mean 0.05, right? 0.05. We lose 5 cents for every hand. So again, according to our interpretation here, we lose 5 cents per hand, right? 5 cents per hand. Correct? So understand, you lose 5 cents. That's it. Not 1.05. We're going to take 120 and we'll multiply it by negative 0.05. That's correct, Cheska. That is absolutely 100% correct. Yes. So for the 3-hour session, we play 120 hands, and for every hand, we lose 5 cents. So then what you expect to lose here is if you multiply, we're expecting to lose $6. That's correct. And again, you're probably looking at it, it says -6. That doesn't seem like a lot. Well, one of the things is that we accumulate losses over time. So you're actually losing a lot more over time at -6, right? You're losing 5 cents. That isn't a ton, but it does accumulate little by little. So the losses stack up a little by little over time. There you go. Yes, Ziggy. Excellent. I approve. So it looks easy on paper, but it's not as easy as it looks necessarily. So uh, oh, okay. That's that. Okay. I had to look at that one. I'm like, oh, what is this? Hello. All right. Any questions about that example? Any questions at all about that example? No questions. Yay! I hope that it now starts to make sense about why yet. I hope it starts to make sense about why expected value is actually very important and why we do keep a consideration there. Question? Go ahead, Cool Dad. Go ahead, my friend. What's my favorite Legend of Zelda game? I would say Legend of Zelda for the Super Nintendo. 10 times out of 10 would play again. I like the heh Majora's. People love Majora's Mask or Ocarina. But Link to the Past, by far and away, my favorite game during childhood. So I would play that game. I would play that game. That game is super fun. All right. We are out of time here for today. So I was thinking we could get to 6-2, but took us a little while to kind of get through these couple examples. So hopefully that has made things a little bit more clear here. Uh, Alright, hello, hello, hello. Hello, I have returned. Alright, I am back. Better than ever. Reasons. Always reasons! Alright, how's everybody doing today? Hope everybody's ready for another rip-roaring day of mathematics. Mathematics. We're in good shape here. Holy smokes. Holy smokes. Alright, hopefully everybody's doing well today. At least I hope so, anyway. At least I hope so today. Hello. Let's take a look here at things. Hey. Alright. Alright, got a few more minutes here. Interesting. Very interesting.
Wow, imagine the world in 2022.
Yeah, imagine that world in 2022. Pretty crazy. I ain't gonna lie. Next year is gonna be even crazier. Holy smokes. Holy smokes. How's everybody doing today? I see some people hopped in the chat. Thank you very much for coming on in. We'll be starting class here in about 6 minutes or so. So we'll be getting going then. Alright. Thank you very much for coming on out here to the stream once again. So appreciate you. Be starting fairly soon. Alright. Hopefully everybody's doing really well today. interesting. Oh, is it? All right, we'll be starting here in about 4 minutes. Alrighty. Hey, everybody. How's everyone? Hopefully everybody's doing pretty good. Gee. Man, how much do I have to do? All right. Hey, it's awkward for me when it's so silent like this. I'm so sorry. It's okay, Lathina. That's not a problem. Some people just don't want to talk. I'm not going to force them to. I just sit and chill and do what I gotta do. I just still got work on the side I gotta do, so. Any plans for this weekend, Athena? By the way? Oh man, that was not nice. Oh, you know what I forgot, Athena? You know what I forgot, Athena? Oh. Yes, you have a baby shower to go to. Wonderful. Wonderful. Oh, thank you, thank you. Oh, you know, I should, oh, I gotta show you something here, Athena. Hang on, I'm gonna go get it. Something special yesterday. See, look, I got me my fix. Yes, I got me my Thin Mints. That is correct. Mm, nice and from the freezer. Yes, I've won the day. Ah, nice and from the freezer, Thin Mints. Yes. Oh man, you can't go wrong. You can't go wrong with a box of Thin Mints. You can't go wrong with these boys. Oh, frozen Thin Mints, the best thing ever. Oh man, forget how good these things are. Hey, Hazelnut, how you doing? You got some Thin Mints here, Hazelnut. Some frozen Thin Mints. Mm-mm-mm. Look, I have a supplier for my quote-unquote. Oh, you gotta try them frozen. Oh no, you're missing out, Hazelnut. Oh no. You have to get them frozen. You have to freeze them. JD, hello. How are you doing today? How we doing? Happy Wednesday, Madison. Happy Wednesday. I hope you're doing well. Yes, Madison, absolutely thumbs up for these Thin Mints that I'm eating right now. Okay, 1000%. And thumbs up to you as well, Madison. Thank you so much. Thank you very, very much here. Yeah, these Thin Mints are outstanding. Okay, there's nothing ever wrong with Girl Scout cookies and Thin Mints. Go buy a box, everybody. There's an app for that. I know there's an app for that because I have the app. Mm-mm-mm. Frozen Thin Mints, the best kind of Thin Mints you can ever eat in the history of mankind. How am I? I'm doing great, JD. I'm doing wonderful. Lots of great positive vibes from everyone here today. First class, a lot of great positive vibes. You guys, a lot of great positive vibes. There's just positive vibes everywhere today on this wonderful Wednesday. That wonderful Wednesday that we have here going on. So absolutely outstanding day today. Absolutely outstanding. And nice weather. Absolutely. Yeah, that's true. I don't walk outside too much, but I'm looking out, you know, between my vertical slats that I call uh curtain thingies, and there you go. It's nice and sunny. You're sick? Oh no. Oh no, you don't have the Rona, I hope. Please say you don't have the Rona. That would be bad. I don't wish that upon anybody. So, hopefully, you have 3 dogs. You have to go outside a lot. Yeah, that's fair. Now the question is, are all your dogs cute? That's the question, Athena. If all your dogs are cute, then that makes going outside even better. So, because if they're like adorable dog, adorable cute, of course, there you go. Yeah, if they're adorable dogs, you're like, oh, you can do no wrong. Okay, it doesn't matter what you do. You're like, I'm gonna just rub your fur, pet your face. Okay. JD, I hope it's not COVID. Okay, my friend. I hope it's not COVID. All right. I really hope it's not COVID. Okay, I don't wish that on anybody. So I wish you, if it's not COVID, I wish you the best of recoveries. Okay, you always got a friend in me here, right? You need to talk or whatever things. If it's something that's gonna be getting in your way, please email me or whatever. Please just let me know, and we can work around that if necessary. Okay, I can always work with you to be in a better position. So that is not a problemo. All right. So put your mind at ease, at least for me. I'm pretty easy to work with. Um, alrighty. Alright, we're gonna get started here. Let's go ahead and get going here. We'll have a few more people probably join us a bit later, but that's alright. Let's do this. Alright, intro time. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we are going to get started here with chapter 6. Okay, so chapter 6, just to let you know here regarding chapter 6, there are only a couple of sections in chapter 6, 6.1 and 6.2. So today we're going to finish up section 6.1 will be on the docket here for today. And then on Monday we're going to finish section 6.2. So this chapter will go by fast. Some chapters in this book here will have maybe 2 or 3 sections in it. So there are not a lot of sections. There may be content, of course, but there are not a lot of sections there, and we should be able to relatively go through those sections rather quickly. So shouldn't take us too much time to do, in all honesty. All right. But today we're going to go ahead and get started with a section 6.1. So let us go to the big board. Thank you, JD. Just let me know. Let me know if anything happens, JD, or this applies to everybody. If we're having health issues or something like that, and we need to work around something, then just let me know, and we can work around that. So it's not a problem. Okay. Um. All right. So let's go to the big board here. To the big board. All right, big board is here. All right. So today we're going to talk about a few things here. Let me go ahead and zoom in a little bit more so it's a bit easier to read. We are. All right, so let's discuss what we're going to be talking about here today. Today we're going to be talking about discrete and continuous random variables. So another type of variable here, a random variable. Compute and interpret the mean of a discrete random variable and compute the standard deviation of a discrete random variable. So we're going to be talking about those 3 things here today. We'll talk about exactly how to find them and exactly the interpretation behind, especially the interpretation here behind the mean of a discrete random variable, which has a lot of different applications, especially here uh, in statistics and in real life as well. All right. Now, let's go ahead and set the basis here for what we're going to be doing here today. Let's take a look here at number 1. So number 1 says, what is a random variable? A random variable is a numerical measure of the outcome of a probability experiment, so its value is determined by chance. So typically the notation here for a random variable is the capital letter, like a capital X, okay? So like P of X. Now, most of the time here, of what I've done here in class, is I've pretty much said what the outcome was going to be, and we find a probability associated with that. So for example, let's say on a 6-sided die, what's the probability that we say roll a 1? All right, and so rolling a 1 here on a 6-sided die would be one of those outcomes when we roll that 6-sided die out. So again, we just assign that roll a 1 concept, we assign that a letter. We assign that the letter X, okay? And we say, okay, X is rolling a 1, or X is rolling, or Y is rolling a 2, or whatever the case may be. Now, what we're going to be looking at here in this particular section is we're going to see a distribution of possible outcomes and their respective probabilities associated with that. Okay, so it may not be equal across the board, but it does have its important uses. And again, a lot of the things that we'll be seeing today, we've seen in pretty much some form or capacity up to this point in some fashion. So we'll see how that looks like when we do a couple of examples. Okay, let's take a look here at number 2. Number 2 says, what is a discrete random variable? Now, we answered this question here, a discrete variable here, back in chapter 1. Way back in chapter 1, and that was one of the questions maybe on the test, is way back in chapter 1, we talk about discrete and continuous variables. And discrete variable here, again, is exactly a discrete random variable. There's no difference in how we look at the definition here. That is a random variable that has a finite or countable number of values. Okay, so that is a discrete random variable there. All right. What is a continuous random variable? A continuous random variable is a random variable that has an infinite number of values. So again, it could take any amount of values. Okay, it has an infinite amount. Fine, that's fair. Now, the important part here is that, of course, that with these 2 definitions, again, you can graph these appropriately if you want to. So a discrete random variable would have points, and a continuous random variable would be like a line because it could take any value in between, whatever 2 values, and you can take in between. So you could graph it a little bit differently if you want to. We're not going to be so focused on the graphs here, though, as we're going to be focused on the actual calculations with the, say, types of random variables here. Okay. All right. Now let's take a good look here at a probability distribution. So what is a probability distribution? Probability distribution is a distribution that represents possible values of random variables and their corresponding probabilities. So they have the same properties as before, the same exact properties, okay? Nothing changes in terms of the properties that we talked about back in chapter 1 and what we're talking about here in chapter 5, pardon me, and what we're talking about here in chapter 6. We know from before back in chapter 5 when we first talked about probabilities that if we add up all the probabilities together of whatever cases we're working with here, the sum of all those probabilities has to equal 1 or 100%, no matter what. Okay, so we know that for a fact. And for part B here, we know that the probabilities has to be between 0 and 1. Okay, so that's, again, the probability always has to be between 0 and 1. You could include 0 and 1 if it's necessary, but still, one of those things that still will hold steadfast and true. So what we talked about back in chapter 5 is exactly what we're using here once again. We talk about a probability distribution. Nothing changes in that regard. Okay, so where is this all leading to? Okay, that's the most important part here. What are we doing with this stuff here? Okay, let's take a good look here at the next part. Number 5. Number 5 says, how do we find the mean/expected value of a discrete random variable? So here we see some notation here about the mean/expected value. So the mean here could be listed as mu of x here, or e of x as for expected value. Now, what we're going to be focusing on here in this section is going to be more related to the expected value part of the game. Okay, so the expected value part of the game here is going to be important, and that's equal to the sigma x times p of x, i.e. the sum of all the random variable, whatever that random variable represents, times its respective probability. We'll take a look at that here in just a second. But expected value, as we're going to see here today, has a lot of implications, like I said, in real life examples. So let's take a good look here at an example here, and we'll see exactly how this works. Okay, so let's take a look here at number 18. Okay, so we'll look at 18 here on the in the book. All right, and let's go ahead and read this off here, and we'll see exactly how this is going to work. All right, so in the following probability distribution, so this is what a probability distribution looks like. It has our x values here, again, our possibilities, 0 through 5, and its respective probabilities with each one. So let's talk about the context here behind each one of these. All right. So the following probability distribution, the random variable x represents the number of marriages an individual aged 15 years or older has been involved in. Okay, so x, if you have 0 marriages, okay, you can see the probability of having no marriages. All right, you have the probability of having 1 marriage, 2 marriages, here's the probability of that, 3 marriages, 4 marriages, and 5 marriages. Okay, so maybe you're in that 0.01%. Maybe you're a person that's over 15 or over and has had 5 marriages. Maybe it could be the possibility you're that rare 15-year-old who's already had 5 marriages. You know, maybe they got married like 5 days in a row after their birthday. I don't know. It could be one of those things. It's a thing, I'm sure. Sure it's a thing. Yeah, yikes. I mean, I don't know. It's kind of odd, but hey, weirder things have happened, okay? There's that guy a long time ago. I'll catch you at off. Okay. All right, have a good one, Athena. Um, no, it could be like, look, there's that. That does sound pretty illegal. I ain't gonna lie. But I believe every state has their own legal age of uh, of marriage to apply for like a marriage license or something. So I didn't think 15 was included. I thought it was 16. but I could be wrong. I know some states are like 18 or something. I don't know. I don't know what it is, honestly. So every state is different in age. Um, those are the oh boy. Yeah, right. I'm just saying, maybe they're like, or how about the people who like what's that? Oh, I got it. How about the people who marry their like body pillow? You know, like, oh, the body pillow is my waifu. Something to that effect. No. I mean, it's happened. I mean, what maybe not here in the United States, but it was I think in South Korea. I'm sorry I tuned back into that. Or married for taxes. Hey, no, there was a guy in South Korea that literally married his body pillow. Yeah. Guy in South Korea married his body pillow. There was a guy in Japan who married his Nintendo DS character. Yeah, I'm talking like Nintendo DS. Uh like OG Nintendo DS character. Like he actually legally married it. I have no idea, but hey, some people got a thing. So I ain't gonna say nothing. You're probably saying that's weird. Like, yeah, that is kind of weird. So strange. Maybe the anime figure. That's if you can't have the character, marry the cosplayer. Um, yeah, true. You've been to conventions, nothing phases you. Okay, fair enough. Fair enough. Nothing should phase you, to be honest. It shouldn't phase you in the slightest. There's a lot of cool. Honestly, you go to conventions, right? You go to conventions. There's a lot of cool cosplays at conventions. Like a lot of people take a lot of time out to do that stuff. I really respect that a lot, to be honest. I mean, is it something that I would do all the time? No. I mean, but yeah, I think people who do the cosplay stuff and put a lot of effort into it, I'm just really impressed by that. So you a dry cleaner? Yes, exactly. You put your wife through the wash. Yes, that's right. It's so weird to say. that sounds that sounds so bad. That sounds so bad. What are you gonna do today? I'm gonna put my wife through the wash cycle. What the hell? like I, that's what's my wife doing. She's doing laundry. No, no, no. I need to rephrase that. She is the laundry. Oh, right. Okay, I got it. So weird. So weird. Oh my gosh. That's so funny. Oh god. Ay ay ay. Yeah, next thing you're gonna have be like boom 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 FBI open up. Okay, so that's totally a possible FBI situation. I could totally see it that way. You're like, that doesn't sound right. All right, let's go through. Let's go through doing some of these for number 18. I promise we'll get through these examples here. All right. Number 18. All right, so we're going to figure out some stuff here. So first of all, let's find out the mean. Let's talk about what the mean is, the mean slash expected value. All right. And we're going to talk about what this actually represents. All right. So, the mean slash expected value. How exactly do we find this here? Well, let's go back to the formula here for just a moment. To find the mean slash expected value, we're just going to take the value and we're going to multiply it by its respective probability. And we're just going to add it together. That's it. That's all we're going to do. So the sum of all of those guys put together, we're going to just see what we get here. So as you can see here, according to the table here for number 18, okay, all we're going to do here is the expected value. Again, that could be labeled as e of x. This is equal to 0 times 0.272 plus 1 times 0.575. All right, plus 2 times 0.121. All right, plus 3 times 0.027. Plus 4 times 0.004. Plus 5 times 0.001. Okay, so all we're going to do is just add those up in the calculator, and we're going to see what we get here. You guys have an answer for me here? I hope you guys have an answer for me here. It'd be pretty nice. Pretty nice if you have an answer for me. You have an answer for me, please. See what you guys get on your calculator here. We will use the calculator here today, by the way, just to let you know. Yes, you're just multiplying them, though. I ain't gonna lie. It's a lot of numbers, but not too many. It's not too bad. Anybody got an answer for me here? Let's see what you guys come up with. That would be pretty great. All right, 0.901. All right, that's pretty close. 0.919. Yes, that is correct. 0.919 is correct. So 0.919 here is absolutely correct here. So I think maybe you mixed up some of the numbers there, JD. So don't worry though, I'll show you a faster way of doing this here. I just show the manual way here. It's okay. I'm gonna show you a manual way to show the manual way first, and then I'll show the automatic way. No worries, I got you. All right. So we got 0.919 here. Now, what does this mean here? This means that on average, the expected number of marriages for a person 15 years or older is 0.919. Now, obviously, there's no such thing as point of a marriage, unless you're half-heartedly into a marriage, or maybe the body pillow example counts. I don't know. In any case, what matters here is that 0.919 is the right around, obviously, right around the is the average here number of marriages that you would expect a 15 plus person to have in their lifetime. Okay, so that again, we have the expectation that it's pretty close to one. All right, that's the expectation that we have here. So the expected value here, that's one insight that you can certainly put in to play here for an example like this. Now, we do have some others here to take into account. We have other questions here to take into account. Let's do the second one here. So the second one here is, hey, let's find the standard deviation and the variance, okay, of this probability distribution. Okay, so that'll be what this last question here on this handout talks about, is how do we find the variance and standard deviation for this discrete random variable. Now, what you see here on the screen, okay, so let me point one thing out here. What you see here on the screen is the formula for finding the standard deviation here for this for a probability distribution. Now, one thing I do want to point out here is you do not need to memorize this at all in any respect, okay? We are not going to be doing this by hand, okay? We are going to do this via the calculator here, but I have just put it on here for the sake of you having the information in front of you here. Oh, okay, that's what happened there. Yeah, that would probably affect that. Um, so let's go ahead and use the calculator here. Let's take the nice shortcut method here, and let's see exactly what we're working with. Okay. So let's bust out the calculator. Okay, and let's go ahead and go through the steps here about how to put in the probability distribution thing. All right. What we're going to do here first is we're going to hit the stat key. Let's hit the stat key here. And we're going to go to edit, go to our tables. Now, if we have stuff already put in, we're just going to highlight that table. We'll hit clear and enter. We'll highlight that, hit clear and enter. We'll just clear out our tables there. Okay. So first, what we want to do here first is in list number 1, we're going to put all our possibilities, all our possible values here. So 0, 1, 2, 3, 4, 5. Okay, we'll have 0 through 5 for that. And in list number 2, we're going to put in the respective probabilities for each one of them. 0.272, 575, 0.121, 0.027, 0.004, 0.001. Okay, so once you have those plugged into your calculator, I want you to go ahead and type in done in the chat. So type done in the chat once you have this entered into your calculator. Okay, so JD and Alyssa are done. Wait for others. Say that they're done here. All right, JD and Alyssa. Anybody else? Madison or Madison, do you have that done there? Hazelnut? See if we have those done in your calculator there. I'll wait another 15 seconds here, then I'll move. Okay. Oh, okay. Thank you. Thank you, Planet. I hope you guys are having no troubles here. So if you're having trouble, just let me know, okay? We can fix that together. Okay. So if we have those numbers in the calculator there, okay, hopefully given enough time to get those in. All right, we're going to hit the second and the mode key. All right, we're going to quit to the main screen here again. Again, this just ensures that we go ahead and have no bad entries there in our lists. All right, so no stray entries. All right, so what we're going to do next here is we're going to go ahead and hit the stat key here. We're going to go over to calc. We're going to go ahead and call upon our friend OneVarStats. Okay, now in OneVarStats, we want our list to be L1. And we are going to have our frequency list. Our frequency list is going to be our probabilities here. So we do want L2 to show up here. So remember, to get L2 to show up in your calculator here, you're going to go ahead and hit the second key and the number 2 key to get L2 to show up on your OneVarStats. If you're using the old school calculator, again, it'll be OneVarStats, L1, comma L2. Okay. All right, so it'll look like that if you're using the old school calculator, just like so. I'm gonna go ahead and hit calculate. Helpful. Okay, so here we have 0.739, sorry, 0.919 there at the top for our mean that we had found from the previous part there. Really quick here, go ahead and type in done once again in the chat to tell me that you got these same exact values. Hopefully you got these same exact values as you had from before. Go ahead and type done if you got these same exact values. Okay. All right. So if we have that, let's go ahead and take a look here. And let's take a look at the results here. So here we see at the top, we see the mean of 0.919. We just found that out. The most important part here that we're looking for is the standard deviation. Now, as you can see here, the standard deviation is right there. We've seen the standard deviation before in terms of its notation. That's 0.7392. Okay. Now, one of the questions that a few people asked me about was they talked about variance. It's like, okay, you got to talk about variance, but you never really kind of talked about how you would find that. Now, variance here is all variance really is it's the square of the standard deviation. So what we're going to do here to find the variance, all right? So if I said, hey, I want to find the variance here, all the variances is we're going to take that full, if we're going to do it properly on like my math lab or something like that, then what I would like you to do here is I want you to take the full decimal you see here on the screen, the 0.7392151243. So I'm going to take this whole decimal here and I'm just going to square it. That's all I'm going to do. Okay, so I'm going to take that whole decimal, I'm just going to square it just outright, and there I'm just going to round after that, and then I'm going to get my answer for my variant. So if I square it, and then here we go, I get my variance here. My variance here is 0.5464. I know some of you had questions about the variance stuff there back in the first set of chapters. So just as a reminder about how you would go ahead and approach that, that's how we do that one there. Okay, questions about that? Oh, okay. All right, hopefully you guys got that down there. Okay. Now I'm going to ask another question in relation. Nay. Nay, indeed. Nay. Nay, I say. All right. The horse challenge has been thrown. So has the gauntlet. Wahaha. All right. Good beans. Okay, so. Ooh. The Moo Crew has come out indeed. Wow, we have a lot of good things happening. All right. Let's go ahead and expand this out here. We got a few more things to talk about, or at least another part of this question here. Remember, we could also be talked about probabilities here, by the way. So let's answer one more part here. So hopefully this is a nice reminder about what we did here in the last chapter. What's the probability of at least? The probability here of at least 2. So let's have you guys answer that question here. What's the probability of at least 2? The probability of at least 2. According to our probability distribution, what would that be here in this case? The probability of at least 2. What do you guys think? The probability of at least 2. How would we figure that out? How would we solve for that? What do you guys think here? This one's like a little tricky, I understand, but that's okay. Probability of at least 2. Well, what cases are at least 2? What cases are at least 2 here? Can you guys answer that at least? So, what cases are at least 2? What classifies as at least 2? Let's at least answer that question here first. What classifies at least 2? Does 0 marriages classify as at least 2? I'll wait for a little bit. You guys can answer from that. Pretty good. Check that there. Yep. All right, I'll wait for an answer, guys. It's fine. All right. Oh, Planet come out with something. Is it that? Yes, it is. That is correct. Very good. That is absolutely correct. Very nicely done. We take the sum of all those probabilities. That's right. So we take the sum of all these probabilities here. Probability of 2, 3, 4, and 5, right? Because that means at least 2. So if we add up all the probabilities that we see here, we add up every single probability here. So we just take 0.121 plus 0.027. All right, plus 0.004 plus 0.001. All right, and if we add these together here, what do we get as our final result? What do we get if we add up these numbers? What do we get? 0.153. Okay, agreed. Alrighty, good beans. Very good. Are there any questions? Are there any questions about that problem? Any questions at all? Any questions? Nope. All right. So at least means more than 2. Not exactly, JD. Not exactly. At least means so at least 2 means 2 or more. Okay? Not more than 2. That means 2 would be excluded. It means 2 or more because 2 would be included. So the wording there, again, be very careful about the wording there. Not more than 2, because more than 2 would be like 3, 4, and 5. 2 or more would be 2, 3, 4, and 5. So that little distinct difference does affect your calculation at the end of the day. So you need to be like pretty extra vigilant about that, about how it's phrased. and how you would interpret that phrasing. Yeah, so be careful about that. That's kind of one of those tricky parts there. Any other questions before we move on? Any other questions? Okay. So, indeed. All right. So the next thing that I want to talk about here is the other example I want to talk about here is where is this used in the real world? Well, if there's one part in the real world where expected values are used very often, that is definitely in casinos. Casinos use expected values quite often to see exactly how much, say for example, how much of the house or the player would win in any given hand. All right. So expected values here, we'll say, we always say the house always wins. Well, exactly, we can actually quantify how much the house will always win per every hand. And again, we'll see exactly how this rolls. So let's talk about blackjack here. All right, so everybody, people know about blackjack. You're supposed to get 21. All right, if you beat the dealer, then you either win some money, you lose your money, or you get 1.5 times your winnings if you get a blackjack, or you push where either side gets nothing. So let's say it's a $20 bet, $20 game. So you could win nothing, and here's your probability of winning nothing. You could win $30, which is getting a blackjack. Okay, so here's a probability of that. You can win $20, which means you beat the dealer, or you can lose $20, which means that the dealer beat you. Seems fair, right? Now, what we want to do here is we want to figure out, first of all, we're going to do it in two parts. The first part here is let's find the expected value of this particular probability distribution for blackjack. And then the second thing that we want to do here is we're going to assume that that if you play blackjack for 1 hour, you get 40 hands. All right, you get 40 hands of blackjack. So you can play 40 hands in an hour. All right. How much will you how much will you win or lose in 3 hours? Okay, so how much will you win or lose in 3 hours? All right. So that's going to be letter B. Okay, so let's have you guys give this a try. I'm going to give you about 3 minutes or so, 3 or 4 minutes. And so we'll come back in 3 or 4 minutes. I want you to give this problem a try here. Try both parts. And then we'll see exactly what we get here for parts A and B. Okay, so let's take 3 minutes here and 3, 4 minutes, and we'll see how we can go ahead and do this problem. All right, let's give it a try. Okay, let's go ahead and take a look here. I'm in about 3-4 minutes here, so let's take a look here and let's see what we get here for this particular example here. Let's look at letter A. Let's find the expected value. What did you guys get for your expected value? What did you guys get for your expected value? What did you guys get for your expected value slash mean? Let's see if you guys came up with an answer here. Hopefully you came up with a good answer. All right. That is correct. Yeah, that's right, JD. Absolutely right. So the way we figure out our expected value here, you got it. So we took 0 times 0.092. All right, very nice, very nice. Plus 30 times 0.0483. All right, plus the 20 times 0.389275. That's correct. And then plus that negative 20 times 0.464225. Okay, and if you do add up all those together there appropriately, we indeed will get here, let's go ahead and so we indeed are going to get 0.05 or negative 0.05. So let's talk about this here for just a second. All right, let's talk about this for just a moment here. All right, what exactly does this represent? Okay, negative 0.05. Because what we want to do is, how is this applicable in a real life kind of application? What exactly does this mean? Well, because this is the important part I want you to kind of take away from the problem like this. Okay, so to be as realistic as possible. So the meaning is this, is that for every hand of blackjack we play, we expect to lose on average 5 cents per hand. So when we say the house always wins, on average, if we played with unlimited money, so let me put that actually here. If we played with infinite money. So if we played an infinite amount of hands, so we had an infinite amount of money and we kept playing and playing and playing and playing and playing, on average for every single hand that we play, we're going to expect to lose 5 cents. Now 5 cents doesn't seem like a lot, but if you do that over time within like a whole bunch of hands, let's say 10,000 hands of blackjack, yeah, you are losing a lot of money over time. Okay? So maybe sometimes you're going through hot streaks, maybe sometimes you're going through cold streaks, maybe sometimes you're winning and losing up and down like this, blah blah blah. But at the end of the day, you're losing on average 5 cents per hand. Okay? That part is true. Right? So not the greatest rate of return when you're playing a blackjack hand. Now, as for letter B, this talks about how much we expect to win or lose in 3 hours. Okay? So how much we expect to win or lose 3 hours. By the way, if you ever go to a casino, like blackjack is as close as you're going to get to a pretty good game where you can make some money. Poker, because you're not playing against the house in poker, you're playing against other people in poker. Um, and then probably the other one. Well, those are the only two. The game you should never play in a casino is roulette. Never play a roulette in a casino. You will forever cry your eyes out at the odds of winning at roulette. They're pretty bad. So, in any case, that talking about that here. I digress. What I do want to talk about here specifically is let's talk about letter B. 1 hour we play 40 hands. How much will we win or lose in 3 hours? What do you guys think? How much will we win or lose in 3 hours of playing blackjack? How much will we win or lose in 3 hours of playing blackjack? What do you guys think? If we lose on average 5 cents per hand in blackjack, how much do we expect to lose? -6. That's correct. That's right, Planet. Very nice. Very nice. So how did you get that, Planet? How did you get -6? -6 is definitely the correct answer. -$6. How did you get that? How did we get -$6? You could just tell me how we got that. Maybe do some there you go. That's correct. Okay, very nice. All right, so we have 40 hands for 3 hours. So we played, in this case here, we played 120 hands of blackjack. Since on average we lose 5 cents per hand, we just take the 120 and multiply it by the -0.5 cents. And so here we get $6. So although 120 hands is quite a bit, okay, again, we still expect to lose, pretty, doesn't seem like a lot, but again, if you take a look at that, that isn't too bad there. Yeah, you want -5 cents. You lose 5 cents. So you expect to lose $6 after playing, on average, after playing 120 hands. Now, so like I said, in the long term, when we do a lot of these trials, a lot of these hands in blackjack, we expect to lose money regardless, okay, of the situation. All right. That's okay. It's not a problem. Are there any questions about any of the examples for today? Any questions? Any questions at all from you guys? Good? Okay. The next test won't be for a while, Planet. It'll be what, 5, 6, 7, and yeah, 5, 6, 7, and 8. So after chapter 8, I think it's 5, 6, 7, and 8. Maybe it was 9, 10, and 4. I forget which way, but it's like after chapter 7 or after chapter 8, we're having the next test. So it won't be for a while yet. I'll make an announcement. So I'll always make an announcement. So that is true. Okay. Well, this is as far as we're going to go here today. We got done a little bit early. Here today. Very good. All right. All right. I want to thank all of you for coming out here to the stream once again. All right. All of you are very wonderful people. All right. Thank you so very much. All right. Thank you very, very much here. I'm going to be on for my office hours here at 2 o'clock, okay, because I know there's some people who may have questions for me. So I'll be back in about half an hour or so, okay? However, in the meantime, all right, Everybody, stay safe, stay healthy, and most importantly, stay sane. All right? Have yourself a very wonderful weekend. All right? Please, please, please take care of yourselves. All right? Enjoy yourselves as much as possible. And I will see you then. Otherwise, I'll see you maybe during office hours here today. All right? Have a good one, everybody. And take it easy. All right? We will see you later. All right? We will see you later. Take care. All right, everybody. Feel better, JD. Feel better, please. Please feel better. All right? We'll see you later. All right, take care. Everybody. Bye.